This is section 11.1. We're talking about circumference and arc length in this section. So let's start with circumference. This should be a nice review from previous years. So I have the circumference formulas here. The first one is dealing with pi times the diameter. And the second one is going to be 2 pi times the radius. And we know this because of the fact that the diameter is twice the length of the radius. So we have to make sure we take that into account. So then I said I have this lovely picture here that'll help me identify the fact that my circumference is around the circle. So coming here, circumference of a circle with a radius of 9 centimeters. I'm going to go ahead and use that second one. So C equals 2 pi r. I know my r is going to be 9, so I'm going to do C to equal 2 pi times 9. Since I'm going to leave it in terms of pi, so I'm going to come over here and make a little note. If I want an exact answer, I want it to be left in terms of pi. And what that simply means is I will not have a decimal unless the decimal is connected to the pi. So I'm not going to go ahead and solve out fully. So, going back to my problem, I have circumference is going to equal 18 pi, and we know that's centimeters. Now, if I want to go ahead and round to the nearest hundredth, just to have that solved for, I can say that this is going to equal just about 56.55 centimeters. Okay. Moving on from this, I'm going to go ahead and see that the radius of a circle, we need to find the radius of a circle with a circumference of 26 meters. So instead of my radius being 26 meters, my circumference is going to be 26 meters. So I'm going to say C equals 2 pi r still, but instead of plugging something in for my radius, I'm going to go ahead and plug it in 26 for my circumference. So I have 2 pi r over here. And I'm going to go ahead and divide by 2 pi on both sides just to get r by itself. So I have two possible answers here. I can do, my radius is going to be 13 over pi meters if I leave this in simplest pi terms of pi. If not, if I want to round to 2 decimals, I'm going to have 4.14 meters. Now be extra careful when you type this into your calculator. Up here, when I type this specifically into my calculator, I have to use the lovely parentheses. If I don't use a parenthesis, what your calculator does is it does 26 divided by 2, and then it multiplies that by pi. That'll end up giving you 40.84, which is larger than your circumference. You cannot have a radius that is larger than the circumference. That does not work. So please pay attention to how you type it into your calculator. Moving on from there, I'm going to go ahead and add in some more definitions. So just like we have arc measure, we can actually have arc length. Arc measure is to the entire measure of the circle. That's my degrees of a circle, which is 360. Arc length is a portion of the circumference. So it's a portion to the circumference of the circle, meaning it's just a part of my circumference. I can add it all together to equal my circumference. However, I cannot add it up to equal 360 since circumference and length is different than measure and 360. So over here in a circle, the ratio of the length of a given arc to the circumference is equal to the ratio of the measure of the arc to 360 degrees. So it's equal to that measure. This gives us this lovely little formula here, or this lovely little proportion, I should say, And that's the one I prefer to use as the proportion, because from here we can go ahead and solve for even more information. For example, I can solve for arc length, I can solve for arc measure, or I can solve for the radius or circumference. This formula, remember, is my circumference formula. So if I'm told to find my circumference, I can actually replace that bottom or denominator of that side with the letter C and actually just solve for it, because there's no need to solve for just the radius and then plug it back in to find the circumference anyways. So just solve for what you need. Okay, let's go down here to my my example number 2. I have 3 parts here. This is all 3 of the possible ways you will see doing all of, or using that proportion, sorry. So we're going to find the arc length. Oop. Oh my goodness. There we go. Length of arc AB. Since I don't know that length, that's going to be X. We're going to do the measure of arc AB, which is different. And that's going to equal my central angle measure, which is 60 degrees. And then we have my radius in this case, which is 8. So I'm going to go ahead and set up my proportion down here. I have length of arc AB. That's going to be over 2 pi r. I'm going to set that equal to the measure of arc AB, and that's going to be over 360 degrees. Now I'm going to go ahead and plug everything in. I don't know the length, but I do know 2 times pi times 8 gives me my circumference. Over here I have 60 degrees over 360 degrees. So let's go ahead and simplify this before we have to cross multiply. My left side is going to say x over 16 pi. And my right side I can reduce a lot. I'm going to get rid of this degree sign because a degree over degree can cancel that specific unit of measurement out, since I'm wanting to leave it in a different unit of measurement since it's length. I want it in centimeters. The other thing is, since I have 60 over 360, I can get rid of those zeros. It gives me 6 over 36, which is an easy reduce to 1 over 6. From here, I can go ahead and cross multiply. So I'm going to come up here. I have 6x equals 16 pi divided by 6 underneath each. To get x by itself, I'm going to say the length of arc AB is going to equal 8 pi over 3. That's that lovely fraction reduce. Centimeters, which is going to equal just about 8.38 centimeters. Okay, so that is the first part. My second part, I'm now finding the circumference. So I am going to find the circumference of this by plugging in everything I do know. In this case, I know the length of XY is going to be 4.19 inches. I know the measure of XY is going to equal 40 degrees. And then I don't know my circumference, which I'm just going to leave as C. Okay, so I'm going to go ahead and say length of arc XY over circumference is going to equal the measure of arc XY over 360 degrees. This gives me 4.19 over C to equal 40 degrees over 360 degrees. Likewise, I can cancel a lot of stuff out and reduce that 4 over 36. I get 4.19 over c is going to equal 1 over 9. From here, I'm just going to cross multiply. C times 1 gives me c, and I'm going to set that equal to 4.19 times 9, and that should give me c to equal 37.71 inches. And that's my second answer. So this is the first two ways to use this proportion. So we are going to go ahead and look at one more way to use this proportion, and that's actually finding the measure of arc RS. So switching colors one more time, I'm going to find the measure of arc RS. That's going to be going with the length of RS, which we know is 44 meters. We know the radius is 15.28, but we don't know the measure of arc RS, and we're going to label that as y. So like I said, set up your proportion. Length of RS over 2 pi r is going to equal the measure of RS over 360 degrees. I have the length of RS, which is 44 meters. That goes over 2 times pi times 15.28 meters. That's going to be set to y over 360 degrees. There's only so much I can simplify here, and I can really only simplify on the left side of my equation. So I'm going to get rid of this meters because I want my answer in degrees. I'm going to go ahead and get rid of this 2 and change that 44 to 22. And then I'm just going to rewrite it 22 over 15.28 pi. And that's going to equal y over 360. Just like before, we cross multiply, changing colors. So if I come up here, I have 15.28 pi times y, and that's going to equal 22 times 360. So I should have 15.28 pi times y equals 7,920. Divide both sides by that 15.28 pi. Notice how I do put that in parentheses. And I should get the measure of arc RS to equal 164.99 degrees. And that is my final answer. So this is using that lovely proportion. I want to go ahead and move on to the next part. Please feel free to pause and go back to this section if you need a little bit extra explanation. But I do want to go ahead and move on to the next section here, as we are getting towards the end and I am running out of time for a good video. So we need to find the dimensions, we have the dimensions of a car tire. To the nearest foot, we need to determine how far does the tire travel when it makes 15 revolutions. This is actually one of the ways that cars actually track how many miles is by tire rotation. That's where those lovely little chips in the car kind of help. And as long as the tires are correct on the car, it can really accurately determine how many miles you travel. So I have 3 steps that I need to do to work through this. The first step, step number 1, we need to find diameter or radius. Either one works. Step number 2, we need to find the circumference. And step number 3, we're going to use this formula. Distance traveled going to equal the number of revolutions. So how many times does it rotate? Times the circumference. Okay, so from here, I'm going to go ahead and make a lovely little squiggly line. And go ahead and start with each step. So I'm going to do step number 1. And that's finding either the radius or the diameter. In this case, I'm going to find the diameter because I have all the information to bring me straight across my tire. So I'm going to say the diameter equals 5.5 plus 15 plus 5.5. That's going to equal 26 inches. My next step, step number 2, is I'm going to find my circumference, which is going to be pi times the diameter, which gives me 26 pi inches. I'm going to go ahead and leave it like that for now. And then finally, I'm going to find the distance traveled. So the distance traveled is equal to the number of revolutions, in this case the problem told me 15, times the circumference, which is 26 pi. When I multiply this together, I get 390 pi, which equals just about 1,225.22 inches. Now, of course, I'm going to go ahead and find the decimal for this because I would not say that tire moved 390 pi inches. I would not say it that way, would I? So I need to go ahead and figure out that lovely decimal that it can result in. However, I'm not quite done with this problem because I'm missing one key piece. I have to figure it out to the nearest foot. So I'm going to come over here and I'm going to say that I know I have 1,225.22 inches, and I'm going to multiply that by 1 foot over 12 inches so I can get rid of these inch labels. This should give me just about, rounded to the nearest foot, 102 feet. And that there is my final answer. So that tire rolls 15 times and hits 102 feet. Okay, last thing I want to do is some conversions. We are going to convert between radians and degrees and then vice versa. So I'll either go from radians, from degrees to radians, or from radians to degrees. Radians are just another form of measurement we can use to measure angles and other parts of the circle. You'll dive more into radians and those kind of measurements when you get into your pre-calc trig class. But for now, I want to go ahead and just learn how to convert these. So, if I have 45 degrees, I look up here, I'm going from degrees to radians. I need to multiply by pi radians over 180 degrees. Whatever I am trying to get rid of, in this case the degree sign, needs to be on the opposite side of my fraction for this to work. So I have 45 degrees on top of this fraction, and I need to multiply pi radians over 180 degrees. What this does is it allows me to cancel out my degrees, and all I have to do is multiply straight across and simplify. So I have 45 pi radians, and that's going to be over 180. This reduces to pi over 4 radians. Okay, so that's my first conversion. I'm going to do my second one, where I'm turning radians into degrees. So I'm going to write this first as 3 pi radians over 2, just so I can have the label on the top. Then I need to multiply. Since I have the radians on the top, I want to get to degrees. Degrees has to stay on the top, and on the bottom is going to be my pi radians. That cancels out my radians. I also cancel out this lovely pi, and I can simplify 180 and 2 to bring this to 90 degrees. So I'm going to do 3 times 90 degrees, which gives me 270 degrees. And if you notice, I chose the smaller of the more simplified of the two fractions that I could possibly choose in each of these conversions. And that just allows me to have to work less at the end in simplifying. I can go ahead and do the simplification first and then simplify more later on. Okay, this will be our circumference and arc length and probably the longest section of notes that you will have.